Good morning, class. Hello, welcome to another ed puzzle video. We're gonna dive into 4.5, graph of sine and cosine. And today I just want to go over something real quick, which is the warm-up. It's not really a warm-up, but it's something I want to show you, so then it'll help you with your graph. So to graph one full cycle of sine and cosine, I would always advise to use the 5 critical points to sketch sine and cosine. And when you ask what is a critical point, so we know the points for sine. So imagine this is our sine graph right here. And we know the points for sine, it's at 0, it's 0. At pi over 2, it's 1. At pi, 0. At 3 pi over 2 is -1. And then at 2 pi is 0. Once you have that point, you can just connect the dots like that. And same thing with the cosine graph, which I'll put right here. Cosine. Same thing, we know where the points are at 0. It's 1, 0. At pi is -1. This is 0. And this go back to 1. And then that just helps us know like how to connect the dots, you know? That's basically all we're doing. So just remember the 5 critical points. That's basically a way to help you know where you're gonna have the points before you even start graphing. So let's go over example 1. So example 1, we're gonna talk about amplitude. And before I dive into that, I want to show you that amplitude is this value right here for both sine and cosine. It never changes. Even if it's sine or cosine, the amplitude is the number in front of the sine or cosine value. And so let's read off amplitude. So an amplitude is the distance between the midline and the maximum or minimum. And let's go over this example, which is y equals 4 sine theta. And I want to reiterate that a, the value right here, or what we refer as a, affects the vertical stretch or compression of the graph. And just to make it clear, if the number is bigger than 0, or no, the 0, 1. So for example, if it's like 3 or 4, then it would vertically stretch. And if the number is in between 0 and 1, then amplitude will compress. And another thing, amplitude will always be a positive number. Even if, let's say for example, that 4 is negative, you'll still say the amplitude is 4. Now that we got that out of the way, what that does now for us is it will just give us a vertical stretch of 4. That's why I have 4 instead of 1 here. Because the original graph, as you remember, if you were doing it without the 4, would just be a rotation of, a little curve of where it'll stop at 1. But because we have 4 here, let's draw a sine graph. But instead of it being 1, now it would be sine of, so let's plug in pi over 2, which is 1. 1 times 4 is 4, so now it shifts it up here. And the same thing. And then this will be -1, but -1 times 4 is -4. And it'll be 0 again. And that's what happens when you have that number 4 in front of the sine. It just changes the where your placement of your points will be. Just remember, it gives a vertical stretch or compression to the graph. Pretty straightforward. Let's go over example 2, which is it says y equals, sine bx minus c plus d. Same thing with the other one. Now you're saying which one does this one affect? Or which one are we talking about for this? This one we're talking about the d value right here. What you can see from the example, y equals cosine theta plus 2. So see that 2 right here. That is very important. So what a vertical shift does is it creates a midline, which acts as the new horizontal axis. So D affects the vertical shift of the graph, which creates the midline. And you're asking, what do you mean by midline, Mr. Nguyen? So the midline you can draw, so it's plus 2. So from positive 2 right here, we have this midline. And then from there, we could just plot our points. So if you remember that it would be from here to here to here to here and then to here. But imagine that, but you shift it up by 2, or you follow the as this is a new midline, as you can see from why we created that midline. So I would create from here to here to here to here and to here. And you see how it creates that new graph for us. And all it does is it technically just shifts everything up by 2. That's how you can picture it. Or you could just draw that midline and then draw the graph from there, wherever works for you. I like the midline one because it kind of gives you a new picture of how you have to draw it versus trying to memorize, try to draw the first graph and then see how it shifts up by 2. So let's continue. So I want you to try this one. This one is 2 sine theta minus 1. But instead of graphing it, I just want you to explain to me, like in word, what happens to this graph, like compared to the parent graph. What does the 2 and the negative 1 do to the equation? Once you're done explaining it to me or answering the question, we will continue. So once you've answered this question, you should see that the 2, causes the stretch of by 2. And then the negative 1 shifts the graph down by 1. So what I mean by that is now I know that this is my new midpoint. Or midline. Not midpoint, sorry about that. And then I can just graph this by, since I know it's sine. And then I know that sine starts right here. But instead of going up by 1, because our amplitude changed, it'll go up by 2. So now it'll go right here. So you go 1, 2. And then it goes back down once you hit pi. And now you go down to 1, 2. And you go back here. And then this is how your graph should look like once you finish. I know you want to graph and picture, but I want you to be able to explain it before, we dive into graphing it. So again, for part B, please explain what this will do to the graph. And then once you are done, we will continue. All right, so if you, are finished, this is what I would like. So you have that it will compress by 1/2 because of it's, less, between 0 and 1. And then you know that we have it shift up by 3 because of this 3 right here. And, that will cause us to have this midpoint. And you're like, this is going to look ugly because of this fraction. Remember, fractions are beautiful. So I know that instead of going up by 1, it would be 1/2 because the amplitude changed to 1/2. So it's not 1 anymore. And then once it hits this, it'll just go right here. And if you don't see how that goes, it's because cosine of pi over 2 is 0. And then, 0 plus 3 is 3. And then pi will be -1. So it'll be -1 times 1/2, which is 0.5. And then, you'll get 2.5. Just to see how you could kind of picture it too. And, we'll just dive in. Same thing here. And then it goes back. All you do is connect the point. Good job if you got this one correct. If not, it's okay. We'll practice more when we see each other in class. Now for the final example, which is example 3. So this one's, we are actually going to dive into this right here, this -c. So for that, the example I want to go over is sine theta minus pi over 2. And you're like, since it's minus pi over 2 and it's a horizontal shift, you're like, I think it moves to the left, right? Because it's negative. But that will be a no. It would actually move to the right, pi over 2. And the reason being is because, from the graphs, if you see the example of, the vertex form, the negative actually makes a shift to the right. That's an example that you can remember. And this one changes the cycle of the, of the equation. So for example, so how a period is, 2 pi. So the cycle for the original would be from 0 to 2 pi. Well, now that we've changed whatever's inside, the cycle is now pi over 2. And then you do 2 pi plus pi over 2. The reason why it's pi over 2 here because it's 0 plus 2 pi over 2, which is pi over 2. And then we can have our final period, which is going to be pi over 2 and 5 pi over 2. You just kind of change 2 pi to be 4 pi over 2, and then you add it together. And you're like, so what did that do? Well, it shifts the graph to the right. So since it's sine, it would originally start from 0. But because of the shift to the right, it actually starts pi over 2. And then it goes, we, change it to how the graph would have originally looked like for sine, which I kind of messed up, but just remember there should be something right here, which is going to be 5 pi over 2. But so let me put it into perspective. The graph will now, this is the new graph. It looks something like that. I know Mission 1 just kind of did really bad right there. Compared to the original graph, which I will put in red, the original graph would have looked like this. As you can see, it shifts to the right pi over 2. So now the new cycle or new domain, if you want to say, for that cycle only is pi over 2 to 5 pi over 2. And now let's go over this one, which is sine of theta plus pi over 2. And, we'll just do what we did earlier. I'll have from 0 to 2 pi. And once you have that, remember it's negative because this is positive. And then this will be 3 pi over 2 once you subtract 2 pi by minus pi over 2. And now just, start plugging it in. And you're wondering, how did I get this? Like I said, everything shifted to the left. from the original graph by pi over 2. So it would just help us see it a little clearer. And like I said, if you don't see it, then, just remember that the graph of the original would look something like this. And it just shifts to the left, pi over 2. All right. So I want you to try this one on your own, but just remember this one. I just want you to explain to me what is occurring within this graph with the given equation, 3 cosine theta minus pi. Once you are done, let's see if your explanation meets what I am going to say. Now that you have done this one or explained this to me, how the graph will look like, let's begin by, just saying the 3, we know that the 3 will cause the vertical stretch of 3. So our amplitude will change from 1 to 3. So because of that number right here. And then the minus pi should cause a shift to the right, or horizontal shift to the right by pi. So originally, just remember it was 0 to 2 pi. Now it would be pi to 3 pi. So now the shift goes to here. It will start right here. And then it will just like how how the graph should look like, or as like I said, let's go back to the original where it would be right here, right here, right here, like that. The original one's in red, and you can see that it just shifts by pi. You see that? So good job. If that's what you said and that's what you pictured, then good job. This is the end of the section. If you have any question, comments, or concern, please say it right now. Otherwise,